making things difficult. So we're going to move on to Andy Stirling. Andy is Professor of Science and Technology Policy at the Science Policy Research Unit at the University of Sussex in the UK, where he co-directs the STEPS Centre. He's got a background in the natural sciences and a master's degree in archaeology and social anthropology from Edinburgh and a PhD in science and technology policy from Sussex. He's a former board member of Greenpeace International, but he's worked in collaboration with a diverse range of organizations. His research interests include technological risk, innovation policy, scientific uncertainty, and public involvement in decision-making. So perfect for our discussion today. And of course, he's also an expert on things nuclear as well. So Andy, I'm going to turn it over to you now. If you're ready. Great.
Yes, I think I am, Alison. Thank you very much for that introduction, and thank you very much to the committee as a whole for the privilege of inviting me to contribute to these discussions. It's an honor to participate. So on this topic that Sheila, thanks also to Sheila for introducing the background to this so excellently, and building on what Sheila has said, I'm going to say a few inevitably idiosyncratic. It's impossible to look at a vast field like science and technology studies and try to distill some of the key messages for issues facing nuclear power right now without missing out an awful lot. So I hope what I say is useful to the committee, and especially as a result of some of the dynamics that Sheila summarized so well. Some of the things that science and technology studies finds itself scrutinizing most closely are the dynamics of power and privilege inside science. And of course, to do that can be a rather inconvenient thing to under a number of different views. So it's no surprise then that sometimes STS views do stimulate a little bit of animation in these kinds of discussions, but it's never been especially in the view of a committee of this kind, the National Academies, I don't think science has ever relied for its authority on being convenient. So I hope what I say will be useful in some way to the deliberations of the committee. So straight to it then, what does science and technology studies have to say about the subject matter of this, sorry, something's popped up, yes, of this present deliberation? Building again on some of the themes that Sheila outlined, one key message that comes out of a key strand of work in science and technologies is that evidence, information, analysis that's presented as science, sound science, evidence-based policy does, despite this mode of presentation, tend to be far more political than is conventionally claimed. This is not a pejorative remark to make, it's simply an inconvenient fact, and one can see this in debates over the years on nuclear power right up to the present day, in that whatever side one takes in these vexed controversies, I don't think it's controversial to note that going back over 40 years or so, evidence initially presented as sound scientific basis for understanding, for instance, core melt frequencies, reactor reliability rates, the costs of electricity, the building rates of new nuclear programs running into the future, have all proven, whatever one views as being the merits and demerits of these programs, proven to be remarkably optimistic. And we've seen them falsified repeatedly, as with other types of technologies. So there's clear empirical evidence then that uncertainties of the kind that Sheila alluded to have been seriously downplayed in these debates. And that is a message then of relevance now, because it strangely continues to be the case that two features characterize much of the discussion of advanced nuclear reactor programs in prospect. In relation to all these kinds of parameters, we still see very precise claims made about all these kinds of parameters without reference to this past legacy, which is not surprising in a field like this, of uncertainty and of a tendency to appraisal optimism. That's a finding that science and technology studies scholarship comes up with, looking at all kinds of technologies. And in similar vein, a general conclusion that STS comes up with looking at across the board at all technologies also applies particularly to the nuclear sector, in that it's typically the case, whether in biotech or in chemicals or nanoscience, neuroscience, etc., but also in the energy sector, the directions available at any given juncture for innovation going into the future are typically far more open than protagonists on any side will be happy to acknowledge. So we see that, for instance, in energy debates across OECD countries in the 1990s. There's not time to go into this, but it's worth bearing in mind the number of times, and the example of the advent of combined cycle gas turbine technology in the late 80s, early 90s, coming in from aerospace is a striking example of this. I've done quite detailed work on these issues, and it's really striking how very sophisticated, comprehensive foresight and technology assessment exercises of the late 1980s, looking specifically at future technologies in the electricity sector, really failed to get to grips with the enormous significance of the technology coming out of aerospace in these combined cycle gas turbines, which came to dominate in some cases, but certainly profoundly influence electricity supply mixes right across the OECD over the space of only a decade. So there's an example of how technology change can proceed in a far more open fashion than appraisal processes of the most rigorous kinds are typically able to see. And of course, we've seen the same thing, arguably, again, although the details vary depending on what side of these debates one is on, the last decade has surely, from any view, overturned the idea that renewables are simply a marginal technology. The manifest evidence on the ground is very different worldwide. And the idea that a sufficient, reliable, affordable provision of electricity services from renewables is simply impossible, physically impossible, is now no longer tenable. One can, of course, take all kinds of views about the relative merits and demerits of different strategies, but to simply rule out an entire family of technologies on the basis of being impossible in ways that were common in these debates going back over decades is simply now impossible. And yet we still see emphatic assertions associated with nuclear debates of ideas that advanced nuclear power is necessary, that it is somehow to be taken for granted that nuclear will feature prominently, if not at least in a significant fashion, in electricity supply mixes. And this isn't a critical point about nuclear power. It is just very striking that nuclear power should benefit from a view that it is somehow automatically necessary. This is a feature of debates that science and technology studies really gets to grip with. And then the third and final of my three key messages from science and technology studies, again, by implication, extending right across the field of research and innovation as a whole, is that all technologies, all infrastructures and institutional configurations around technologies embody power relations in very strong but often quite hidden ways, because we tend in modernity to speak of technology and science beyond that as if it were value-free, free of interest, free of power relations, and it does an extraordinary job. I'm an enormous admirer of science to the degree it manages to compensate for these kinds of structures of power and privilege, but nonetheless it would be eccentric to really sustain a claim that science and technology are free from structures of power and privilege. So this is, of course, not exactly new. When we look at the debates over climate change, we see that until recently, the fossil fuel infrastructures, fossil fuel regimes, socio-technical regimes, to use a jargon word from science and technology studies, were not only effective in engineering terms at excluding other kinds of contributions to energy mixes at the degree that they were possible, but also in influencing our imagination, society's imaginations about the kinds of alternatives that are possible, even in principle. And I would say, at the risk of being a little bit controversial, that the focusing of debates now around nuclear power, it's certainly true in the UK, it's true in France, through much of the European Union discussions, and I think it's true here too in this present discussion, tends to be far more around what can nuclear power do, rather than what would be best. A little bit like the individual with only a hammer, every problem is a nail. We sometimes tend to frame the debate simply around taking for granted nuclear power, despite the experiences I've mentioned. And I think a reason for that, based on quite a lot of work that's emerging, especially strongly in recent years, is that the assumed inevitability of the civil nuclear industry, in whatever form, advanced forms coming on stream now, is stabilized by the intensity and depth of military nuclear interests. It's really a matter now of government statements in countries like France and the USA and the UK, even although they're a bit more coy in the UK, that it's recognized that without the infrastructures and the industrial base, largely funded by trickle down from electricity revenues from civil nuclear power, the shared skills, research, infrastructures, regulatory capabilities that all countries need for the military side as well, for instance, in the construction of nuclear propelled submarines, would simply not be either possible or certainly affordable. So this, like a mismatched galaxy, the shape of the galaxy is inexplicable in terms of this missing mass. There's a missing mass there too, which helps explain why we tend to frame discussions, as we are indeed in this discussion, in terms of what can nuclear do rather than what would be best. So the practical upshot then, quickly, to try to be concrete in some of the implications of debates of the kind we're in now, is basically to recognize and, if we want to be rigorous, balance for the effects of power that I've tried to document in the framing of nuclear policy debates in order to be more rigorous about these things. So one conclusion from that is to focus at least as much, really preferably a lot more, on what the challenges are for energy or for climate, rather than what the challenges are for this particular technology, nuclear. Secondly, to give balanced scrutiny to the pros and the cons of alternative zero carbon strategies as to nuclear strategies. It tends to be the case, especially in presently nuclear equipped countries, that massively more attention and a lot of the time much more research effort goes into nuclear than all the other strategies put together. A third one is to be rigorous about the assumptions about the potential for advanced nuclear technology is actually often, as I think we may have heard in earlier discussions, much older in the nuclear tradition than we might think. Some of these new design concepts were around quite a long time. But nonetheless, it's important to make sure we give due scrutiny to these, but it's also important to give equal scrutiny to advanced forms of other technologies, which are in fact proceeding with technological change at far faster rates quite often. A fourth point is to focus on empirical realities rather than theoretical constructs. A concrete example of that is with relation to the historical associations between uptake of different technologies, nuclear or renewables, and reduced carbon emissions. And it's a remarkable fact that the literature on the empirical associations with carbon emissions reduction and uptake of different low carbon technologies is really barely started. I've done some work on this, published in Nature Energy with colleagues, pioneering this kind of approach. It's certainly a lot more scope for it, but already at the moment it seems to be the case that there's really no basis for the assumption that nuclear offers preferable means empirically to achieve these kinds of ends. A fifth conclusion is to attend to processes of path dependence, of lock-in, of crowding out. These are crucial in real-world infrastructures. Adoption early of some technologies can close out others. That says nothing about the pros and cons of whichever technologies one looks at, but it does mean to simply say we need everything is a very naive and potentially quite accident-prone way of approaching portfolios of technologies. And as part of that then, the quality of diversity, which is a vital quality and is often neglected in energy sector as elsewhere, does not mean let's do everything. As in fact, for reasons we can, in fact, a highly irrational approach in the light of a lot of the literature looking at diversity, it means make choices about portfolios. It does not mean we have to do everything irrespective of costs or other pros and cons. I think there's also a message to be candid about the global military drivers of attachments to nuclear infrastructures. This is not necessarily a bad thing, like power itself, it's not a bad thing. It just can become a bad thing if it's not attended to. And so a lot more candor and explicit rigorous scrutiny is required to look at the different scenarios for each of those technologies in the absence of another. And then finally, I think to treat obsolescence in a reasonable way. Obsolescence of a familiar experience, we're witnessing it now with fossil fuels, arguably, it's a long process. There is no reason in principle why any technology, including nuclear, should be assumed to be immune to obsolescence. So our discussions of nuclear then should not, of course, assume that such a thing is happening, but the possibility that it is should be part of the debate. And that again goes back to the framing of things in terms of what can nuclear do, would be better to be framed as what would be best for energy and for the challenge of addressing climate change. So thank you very much for your attention.
Thanks very much.